We have both flow control valves have closed. The fill and drain valve is still open.
Roger. ALC.
ALC.
Roger. LH2 right now is stop flow due to the PLIS probe indicating. Please convene the anomaly team and give us a recommendation.
Roger. Anomaly team to channel 14.
T-minus 50 minutes.
This is Atlas Launch Control at T-minus 50 minutes and counting. With a single 10-minute built-in hold remaining, that means we are exactly 1 hour from the launch of the Mars Reconnaissance Orbiter on a Lockheed Martin Atlas V rocket from Complex 41 at Cape Canaveral. At this point, liquid oxygen on the Atlas stage 77% full. We're at flight level on the Centaur and preparing for the loading of liquid hydrogen onto the Centaur very shortly. We're joined now by Tammy Harrington, the Mission Integration Manager for NASA at the Kennedy Space Center, who's been busy working the integrated operations on the MRO spacecraft and the Atlas V for quite some time. Tammy, welcome. And about when did Kennedy Space Center actually start preparing for this launch?
Actually, the Launch Services Program began working with the MRO project about 4.5 years ago. And it began with the exercise to actually buy the launch vehicle and select the launch vehicle that would be appropriate for sending it on its mission to Mars.
And then the team that you work with has a lot to do with the interface requirements, do they not, between the Atlas and the spacecraft? What do they need to be compatible to work together?
Correct. We manage the process by which the launch vehicle and the spacecraft actually come together, and we have to determine what needs to be done on the launch vehicle in order to accommodate the spacecraft, and how the spacecraft basically has to be designed in order to fly successfully on the launch vehicle on its mission to Mars.
So what was the main thing in choosing an Atlas V? What are some of the things that led NASA to believe that that was the right vehicle to fly this mission?
Basically, we put together a list of requirements on the spacecraft side related to the performance that's required and due to the mass of the spacecraft and the instruments that it wanted to fly. We also looked at the trajectory it needed to fly in order to get to Mars, and the Atlas V proved to be a very good match with meeting all of those requirements, in addition to the other special accommodations that the spacecraft required in its processing.
We're going to look some of at some video now of the Atlas V processing, the Atlas and the Centaur, beginning with their arrival. And Tammy, if you can talk us through this.
Sure. Here you see the arrival of the Russian Antonov cargo plane arriving on March 31st of this year. It brought the first of the launch vehicle hardware that was going to be here for processing for MRO. It is known as the Common Core Booster, which is the first stage of the Atlas V. It arrived at the skid strip at the Cape Canaveral Air Force Station. The Common Core Booster is built by Lockheed Martin in Denver. And here you see the process by which it was loaded off of the airplane and placed on the flatbed truck in order to begin its roll to the Atlas Spaceflight Operations Center. This is the trip that it took to get to the high bay, and the ASOC previously was used for Titan IV solid rocket motor processing, and it went through a facelift and an expansion in order to accommodate the Atlas V. Here you see it moving into the high bay, where it performed powered-on testing of the stages and is stored until it rolls out to the vertical integration facility, which you see here. This process actually occurred on May 6th, and where it took its 4.1 mile trip out to the vertical integration facility. The picture you saw there was of the actual vertical integration facility is 293 feet tall, and this is where the rockets actually come together. It's located about 1,800 feet from the actual pad where the mission will be launched from. It features a 60-ton crane, which will hoist the segments of the Atlas V up to the mobile launch platform. This vertical integration facility is designed to withstand 140-mile-an-hour hurricane winds, and it has 7 automated movable platforms to allow access to various areas of the rocket. Now, this Common Core booster is 12.5 feet in diameter, and it's about 106 feet tall, and there you see a picture of the Russian-built RD-180 engines, which actually power this stage of the launch vehicle. It is fueled by liquid oxygen and an RP-1 kerosene mix, and it will provide a liftoff thrust of 860,000 pounds. There is approximately 450,000 pounds of liquid oxygen that will be placed on board this stage, as well as 169,000 pounds of RP-1. And here you see the process by which this was placed in its vertical integration facility and waiting for the next piece of hardware to arrive. This hardware, this picture here shows the arrival of the Russian Antonov plane yet again on the 6th of June. And this is where the Centaur upper stage came in, which is the workhorse of the Atlas program. And once again, here it is shown taking off to go toward the Atlas Space Flight Operations Center high bay. Once again, it would undergo pre-hoist testing prior to its move to the VIF, which occurred on the 17th of June. The Centaur for this is actually 10 feet in diameter. It's a structurally stable booster, and it's over 41 feet in length. Here you see the vertical integration facility doors rolling up, which are approximately 41 feet wide and 270 feet tall. They are reinforced fabric doors that will move up to allow for the individual Atlas V stages to be lifted up into the building. Now, the Centaur, there you see the designation of our mission here, the Atlas V 007 is the tail number for the MRO mission. This Centaur is powered by an individual RL-10 Pratt & Whitney engine, and it is fueled by liquid oxygen and liquid hydrogen and provides about 22,000 pounds of thrust. It is a restartable engine and is capable of multiple firings in space separated by coast faces. Now, for the MRO mission, we actually will perform 2 Centaur burns. The first one will last about 9 minutes to inject the Centaur in a parking orbit, where it will coast for about 30 minutes to its optimal position prior to the start of the second burn, which lasts for about 5. And there you see the final configuration with the first 2 stages together. The next series of pictures you'll see here are sequences of an Atlas V wet dress rehearsal. We actually performed 2 of these dress rehearsals for the MRO mission, one on July 7th and one on July 19th. This is a test of the simulation of pre-launch countdown operations as well as a fueling of the rocket. The Atlas V launches are controlled from the Atlas Spaceflight Operations Center, which houses the Launch Control Center you see here. All the officials, the engineering team, and customers that execute the countdown are actually in this facility during the countdown itself, as well as during the tests, which were known as the wet dress rehearsal. And there you see the final configuration upon fueling of the rocket. It's pretty unique here from the fact that the spacecraft encapsulated in its fairing had yet to be placed on top of the vehicle. That process began here on the early morning hours of July 28th, where you see the MRO spacecraft encapsulated in its fairing and rolling out to the vertical integration facility, and there it goes by the shuttle vehicle assembly building on its way there. The vehicle had been processed previously at the Payload Hazardous Servicing Facility since the April timeframe, and it went through a series of tests in order to verify its readiness for encapsulation and eventually for launch. And on the way out to the pad, we had to monitor and maintain all the environments in the fairing in order to make sure that the instruments were actually safe and secure and maintained at the temperatures and humidity requirements that they needed. The version of the fairing that we actually fly for the MRO mission is a 4-meter fairing, which is about 14 feet in diameter and about 40 feet long. It's built in by Lockheed Martin in Harlingen, Texas. Obviously, you can see that given its relative size, it's a pretty large spacecraft that's encapsulated there. And in its final configuration, it's 188 feet high and it has a gross liftoff weight of 740,000 pounds.
Well, Tammy, after it's on top of the rocket, what are the things that they have to do from that point to launch?
Actually, we underwent a series of integrated systems tests, which were to verify the electrical compatibility between the launch vehicle and the rocket. And the spacecraft itself also went through battery conditioning and reconditioning, as well as cover removals, and then some functional testing as well to verify its systems were functioning nominally in order to get us to this point today.
Has the spacecraft got their own set of tests that they have to complete as well, or is it all an integrated thing?
Some of them are integrated and some of them are separate. There were some integrated things related electrically, but there were also things that the spacecraft had to do individually.
Well, Tammy, thank you very much. I'm sure you're looking forward to see the fire in the hole, as everyone calls it. And thank you very much for talking with us.
Thanks, George.
Thanks. We're at the point where the liquid hydrogen, or rather liquid oxygen on board the Atlas, that is nearly complete. We should hear that wrap up here in a moment, and we'll start on liquid hydrogen loading. T-minus 39 minutes, 43 seconds, and counting. This is Atlas Launch Control.
7.5% fast fill complete, topping in progress, step 241.
Roger. Step 242, ECBs at flight pressure. Roger. T-minus 38 minutes.
Atlas LO2 at 99.6%, step 243.
Roger. Cycle Atlas LO2 fill and drain valve.
Roger.
T-minus 35 minutes.
This is Atlas Launch Control at T-minus 31 minutes, 47 seconds and counting. Still continuing toward a launch time at 9 o'clock Eastern Time this morning. Once the Atlas V leaves the pad, the tracking data and telemetry will come back to the Atlas Space Operations Center initially via the tracking antennas located at the Kennedy Space Center and Cape Canaveral Air Force Station. It will also be acquired by the Air Force Tracking Station at Jupiter Inlet approximately 50 seconds after launch. The Air Force Downrange Tracking Station at Antigua Island will acquire the vehicle 6 minutes into flight, followed by acquisition through NASA's Tracking and Data Relay Satellite System, which acquires from launch plus 11 minutes until spacecraft separation. The MRO spacecraft acquisition will occur about 4 minutes after separation occurs through a tracking station at Tanegashima, Japan, supplied to NASA by JAXA. And it will be followed by the Jet Propulsion Laboratories Goldstone Deep Space Network Tracking Station in California approximately 20 minutes later.
Perform pogo suppressor charge.
At this time, the liquid oxygen is aboard the Atlas and the Centaur. We are standing by for the start of liquid hydrogen loading, which should begin shortly after the vehicle engineering team finishes a discussion about proceeding with the loading. And that will be the final major activity to be done in our countdown activities before we get into terminal count.
T-minus 30 minutes.
At T-minus 30
COPV at
minutes
flight
and counting, this is Atlas Launch Control.
LC Anomaly Coordinator on 1.
Go ahead.
Roger, LC. With respect to the hydrogen tanking operation, the Anomaly team would like to recommend that Fluid Software go ahead and change the offset values that are within CCLS for the PLIS liquid level measurement. And then we will manually, the Centaur LH2 operator will manually tank the vehicle to the 5% level using the topping valve. At that point, we'll stop tanking and reset the software and proceed with tanking via the normal tanking software.
Roger.
T-minus 27 minutes.
Fluid Software, LC.
Progress suppressor charge complete. Step 267.
Fluid Software, LC.
This Fluid Software, go ahead.
Roger, are you prepared to change that offset value for the PLIS measurement?
Roger.
Roger, proceed.
Roger that.
LH2, LC.
Go ahead.
Are you prepared to manually tank using the topping value to 5%?
Roger.
Offset has been returned to its original value.
Roger, proceed, LH2.
This is Atlas Launch Control at T-minus 25 minutes 5 seconds and counting. standing by now to begin the liquid hydrogen loading of the Centaur stage. And there is some discussion about whether or not they would prefer to tank the first 5% manually and then turn it over to the computers from that point. But at this point, plans are to continue with our tanking operations to lead to launch at 9 o'clock this morning. The Mars Reconnaissance Orbiter will reach Mars in 2006. It will enter a highly elliptical orbit around Mars, which will gradually become near circular with an apogee of 199 miles and a perigee of 158 miles above the surface, orbiting Mars every 112 minutes. This orbit is approximately 20% lower than any of the 3 current Mars orbiters. The lower orbit adds to the ability to see Mars in detail as it hasn't been seen before over a period of at least 25 months or longer. The orbiter carries the biggest communications antenna ever sent to Mars, relaying higher resolution imagery than has ever been seen previously. The oversized solar arrays generate 6,000 watts of power near the Earth, but once in orbit around Mars, generate 2,000 watts due to the increased distance from the Sun. Mars Reconnaissance Orbiter should provide a fidelity and level of detail of the surface of Mars similar to some of our most sophisticated Earth-orbiting satellites. We should have one more weather briefing before we enter the terminal phase this morning, so we're standing by for that. Once the launch occurs, spacecraft separation should occur approximately 58 minutes after launch. Right now, the countdown, the flight termination system open loop tests have just been completed. That's part of our range safety system checkout protocol. At T-minus 22 minutes, 22 seconds and counting, this is Atlas Launch Control.
T-minus 22 minutes. T-minus 21 minutes.
Begin primary adjust parameter transfer.
Roger.
LC, this is CLH.
Go ahead.
Okay, we are at 100% open on the topping valve, and we are slowly levels rising to 5%. Ready to start opening the flow control valve.
Roger, stand by.
LC anomaly coordinator on 1.
T-minus 20 minutes.
ALC, anomaly coordinator.
Go ahead.
Roger, the anomaly team would like to continue the topping past 5% at this point while they're running a SIL lab, continuing the topping and/or tanking mode until manually until the SIL lab confirms the switching back to the automated software.
LC, this is CLH.
Go ahead.
We just went into a stop flow drain.
Roger.
This is Atlas Launch Control, T-minus 19 minutes and counting. We have approximately 5% hydrogen on board and have stopped at this point while the anomaly team investigates
LH2 LC.
data that indicates that we're not
Attempting
ready
stop.
to proceed
No,
with an
we're stop
automated
flow. Both flow valves are full open
automated
and
process of
drain valve
filling.
closed.
Roger. ALC LC.
ALC.
Roger, be advised we're at 5%, but we're also on a stop flow.
So we are at 5% right now. We've stopped flow for the moment
100% open with the fill and drain valve
while they
closed.
talk about the process for
Please convene the anomaly.
proceeding.
Give us a recommendation.
At T-minus 18 minutes,
Roger, I
10
believe it's
seconds.
being worked on
And
now.
counting,
Right
this
now.
is Atlas Launch Control.
T-minus 18 minutes. T-minus 17 minutes. T-minus 16 minutes.
Flight control, final preps are complete.
Roger.
T-minus 15 minutes.
Perform GSE shunt, Cal.
Roger.
TSE shunt cowl is complete.
Roger.
Engine FIV is closed.
Roger.
T-minus 12 minutes. T-minus 11 minutes.
Target set, Tango Sierra _ 2050, and primary adjust TechHex file, adjust _ Alpha Victor 007 _ 07.thx. An SDL CRC of 3 Delta Echo Echo has been received, verified, and loaded into the INU.
This is Atlas Launch Control at T-minus 10 minutes, 33 seconds and counting. At this time, there is discussion underway about resuming tanking of the Centaur liquid hydrogen manual up to about 25%. The fill of the Centaur hydrogen stopped at 5%. And this is believed to be a sensor issue as it relates to the software in the computer that fills the Centaur. So they're discussing the alternatives to pursue this tanking manually. And they're looking at some software.
As well, you can see the isolated showers off the coast. Again, none of those pose a threat to the operation. Winds out at Complex 41 are light and variable, and they should persist with light and variable through the balance of the window. In terms of the peak speeds, winds are presently at about 3 knots, and they've been relatively light for the last couple of hours. Pose no threat for the operation as well, or violating any constraints. Temperature should be in the 80 to 82 range for the through the window. In terms of the ops forecast, looking at scattered low and scattered high clouds, unrestricted visibility, winds variable at 5, temps in the 80 to 83 range, and constraint violation less than 10% for the balance of the window. This is a look at the current profiles. Little change in the profiles, and don't expect much change to the balance of the count. In terms of the LCCs, also all LCCs are presently green and expected to remain green through the balance of the count. And in terms of an exposure forecast, through the balance of the count today, 0% probability of lightning within 5 or winds exceeding 25 or 26 knots. In terms of proton flux, 50 MeV energetic particles remain at normal background levels and expected to remain so. This concludes the weather brief. Are there any questions? LW out.
T-minus 8 minutes.
Switch all secondary decoms to RF link.
Roger.
Read on 270 complete.
Roger.
This is Atlas Launch Control at T-minus 6 minutes, 6 seconds and counting. While engineers continue to discuss the problem of fueling the Centaur, which appears to be a software issue as it relates to the sensors on board the Centaur, the launch time is being adjusted to the end of the window so that we would now target launch at 9:35. Meantime, the NASA chief engineer, the NASA launch manager, the Lockheed Martin launch director, and Lockheed Martin Engineering are all conveyed on the anomaly channel to discuss whether or not we're having a situation that we can explain as far as the computer software and whether or not we should continue today. So at this point we're counting. The new launch time is 9:35. And we will stand by for whether we are going to be able to resolve this. And as we heard, launch weather at this time is go. At T-minus 5 minutes and counting, this is Atlas Launch Control.
Perform water deluge system actuation pressure adjustment.
Roger. Atlas L2 at flight level, step 275.
Roger.
T-minus 4 minutes and holding. This is a program 10-minute hold.
Launch Director, LC. Launch Director, LC.
LD Channel 1.
Roger, recommend we add 35 minutes to our hold.
Roger, concur.
Com, LC.
Com.
Add 35 minutes to our hold time.
I'm sorry, say again.
Add 35 minutes to our hold time.
3-5.
LD, Range Coordinator 1. LD on 1. LC, Range Coordinator on 1.
Go ahead.
The new T0 of 1335 Zulu has been confirmed.
Roger.
This is Atlas Launch Control, T-minus 4 minutes and holding. The anomaly team has continued to discuss this problem, and it appears that we're likely to not continue, that we're going to scrub for today. Now, that announcement hasn't been made yet, but we're standing by here for the official announcement that we'll begin securing. We're standing by for an official declaration. And NASA Launch Manager Chuck DeVal has just announced that we are scrubbing for today, 24-hour scrub. We will attempt to get Chuck DeVal here on console or his deputy to explain what's happened. We are officially scrubbed for today. It's a 24-hour scrub, and we're going to begin detanking. So we'll be standing by here to get some official explanation of what's happened. It was at the beginning of tanking of hydrogen onto the Centaur stage that a problem developed,
LC anomaly
particularly
coordinator
with
online.
the customary automated process.
Roger, LC. The anomaly team at this time recommends
And
standing
it
down
appeared to
for
be
today's
something
operation.
related to the
We just don't have enough
sensors on
time
the Centaur and the computers that
evaluate and
do the
understand the LH2 tanking system
filling
phenomena.
of the hydrogen onto the Centaur. But we're going to try to get Chuck DeVal to come over and talk to us about what's happened at T-minus 4 minutes and holding with a scrub for today. This is Atlas Launch Control.
Our recommendation is that we scrub today's operation.
I concur, and we will proceed into a nominal detanking effort. Is that correct?
Roger, except for the LH2, of course.
Roger, concur.
All stations LC, today's operation has been scrubbed.
LC OSM on channel 1.
Go ahead, OSM.
Yeah, I'd like to adjust the roadblocks and drop the flight hazard area, go down to the BDA for detanking like we do in WDR.
Roger, proceed.
Copy.
All stations LC, we're on page 99, step 4.1. Terminate option 910 and 392 and reset 910 flags.
Roger. LCGC.
Go ahead.
I'd like permission to take everybody back to hardline.
Roger, proceed.
Roger. Options 910 and 392 have been terminated and flags have been reset.
Roger.
This is Atlas Launch Control. We have scrubbed for at least 24 hours. We expect to have NASA Launch Manager Chuck DeVal or Deputy Launch Manager Omar Baez come to our console here in about 10 minutes after they've had a chance to get a full handle on where we're going from here.
Roger.
What the plan is and what work we need to go do. If we launch tomorrow, the launch window is exactly 2 hours in duration. It's 7:43 to 9:43 a.m. Meanwhile, we're beginning the work to detank the Atlas Centaur. Project Manager Jim Graft for MRO reports that the spacecraft has now been deconfigured from its launch configuration and launch posture.
Between 80% and 60% full.
Roger.
And the discussion right now is who are the right people they need to have on the anomaly team to talk about what's actually happened in this system that appeared to be putting us into a posture of having to tank the Centaur with hydrogen manually, which they decided against doing.
Start Centaur helium bottle venting to 300 psig.
Roger.
And hopefully very shortly we can also pass along to you a weather forecast for Friday. At T-minus 4 minutes in holding, we'll not be coming out of this hold as we know. This is Atlas Launch Control.
Secure CEC and activate safety purge.
Roger.